Expand and condense log expressions. Our objective here, we want to expand and condense logarithmic expressions. So what do we know? Well, we know what a logarithmic function is. It is any function of the form y equals log base b of x, where b, the base, is both positive and not equal to 1, and x, the argument, is positive. We also know these three properties, or these three rules of logarithms. We know the product rule. The log of a product is equal to the sum of the logs of the factors. The log of a quotient is equal to the log of the numerator minus the log of the denominator. And the log of a power, where the argument is raised to a power, is equal to the power of the log of the argument, what's remaining there, the power rule or power property. Okay, let's make use of these to expand and condense log expressions. Okay, expanding means we want to take a single log expression and we want to totally expand it. We want to write it as a sum, difference, or multiple of logarithms. In addition to, if we have any numbers that come out, we want to simplify that as well. We'll see an example of that in example 2 here. But we're taking a single log and we are writing it, we're going to apply these to write it as a bunch of logs to expand it out. Okay, example 1. Use the log properties to expand this expression, log base b of x squared times the square root of y, as much as possible. Okay, I'm going to rewrite what I have here. The log base b of x squared times the square root of y. And you notice I said times, so I can apply the, and I'll slide this up a little bit, I can apply the product rule. The log of a product is equal to the sum of the logs of the factors. So this is the log base b of x squared times the square root of y, plus the log base b of the square root of y. Okay, now I can apply the product property, the power property to this one. Log base b of the argument squared, I can put the 2 and make it a multiple, 2 times the log. So this is, I'll just kind of draw the arrow here. 2 times the log base b of x. And I'm going to write the square root of y in its exponential form. So this is the log base b of y to the 1/2, because then I can apply the power property again. This can go to here. Okay, remind ourselves that the square root of y is the same as y to the 1/2 power. Those are equivalent. And so I can expand this. The first piece here is totally expanded. 2 log base b of x. And the second piece, the power rule, allows me to pull the 1/2 in front and write it as a multiple. So it's 1/2 times log base b of y. And I have totally expanded this single log expression into a sum, in this case, a sum of logarithms. And also notice the multiple. This is 2 of these. This is a half of these. So I've gotten rid of all the pieces and I've got all the powers in front, if you will. Okay, example 2. Let's take a look at a second example. Use log properties or rules to expand this one. A lot going on here. Log base 6 of the cube root of x divided by 36 times y to the 4th as much as possible. Okay, I'm going to rewrite what I have here. So log base 6 of the quotient cube root of x divided by 36x to the fourth. Well, the primary operation is division, and so I can use my quotient property. The log of a quotient is equal to the log of the numerator minus the log of the denominator. So I'll come back to here, and this will be the log base 6 of the numerator, which is the cubed root of x, minus the log base 6 of the denominator. Whoops, I put a b there, not a 6. Let's put a 6 there. Of the denominator, which is 36x to the fourth. Okay, well, I can rewrite this one as a power, and this is a product. So let's do those two things at the same time. Rewrite the cube root of x as a power is the log base 6 of x to the 1/3. The reason I did that is because now this can move in front, and I can write this as a multiple. And I'm going to write this as a product. Okay, so I'm subtracting this. I need parentheses here. Okay, so I'm going to subtract the log base 6 of 36 plus the log base 6 of x to the fourth. Now notice, I'm subtracting this. So if I rewrite this, I'm subtracting the whole thing. So that's why I wrote it in parentheses. Okay, the log of this is equal to that. So I subtract this, which means this negative gets to distribute in order to get back to here. Okay, so let's see. This is actually 2, so I can simplify this. You pull out a calculator if you want to. The log base 6 of 36 is 2. And this, of course, has a power. I'll use the power property. So this is 1/3 of the log base base 6. Getting my bases messed up. Of x minus, well, this is a minus 2, the log base 6 of 36. Put it in a calculator, that's 2. And then I'm going to distribute this minus 4 times the log base 6 of x. And now this single log has been totally expanded. In this case, I've got some differences. I've got a number in the middle, and I've got some multiples going on here. Let's go the other way, and let's condense. The opposite of expanding is condensing. Get my paper straight, I hope. Okay, write the sum or difference of 2 or more logarithmic expressions as a single log. We're just going backwards. So here I have 2 logs, and I want to turn it into a single log. Okay, this is the log of 25. I'm just rewriting it, and this is the log of 4. Now let's remind ourselves, when I don't see the base written, then I have a common log, and so it's base 10. So if you want to put a little 10 in here so that you can see it, that might be helpful. I have a sum of logs, and so I can rewrite this as a product of the arguments, okay? So this is the product rule going the other way. Okay, the log base 10 of a factor plus the log base 10 of a factor is the log base 10 of the product. So this is the log, and I'll put a 10 in there, of 25 times 4. Okay, now go backwards. Log base 10 of a product equals the log base 10 of the factors, the log base 10 of a factor plus the log base 10 of the factor if you go backwards. Okay, well, the log base 10 of 25 times 4 is the log base 10 of 100, and this comes out to be 2. So not only could I write it as a single logarithm, I could go further, because 10 squared is 100. That actually comes down to the answer of 2. Let's do one more condensing example. Okay, hopefully I think I'm still in focus. Let's use those log rules to write 2 natural log of x minus the natural log of x plus 1 as a single logarithm. Okay, so I'll rewrite it. 2 natural log of x. We know that the natural log has a base of e down here, but we're not going to worry about that yet. But we know we have an implied natural number e in our base. Okay, first things first, I've got a number out in front. I can't apply the quotient property because I have a 2 here. So this 2 needs to shift back to the squaring the argument. So the natural log of x squared minus the natural log of x plus 1. Now I can apply the quotient property. I have a difference, numerator minus denominator in this case, so now I can apply the quotient property. This is the natural log of x squared divided by x plus 1. And so I've now written this as a single logarithm, the natural log of x squared divided by x plus 1. So there you have it, using those properties to expand and condense logarithmic expressions.